Okay, so I wrote this program in Excel that some of you may have seen, Solo Simulation. Don Gutierrez and Landon Thompson were kind enough to test the program out for me today at the track, and I'm going to show you some results from their runs. First, let's take a look at Don's run. The map in the center is a map of his racing line. The blue is just the curved areas on the racing line. The table on the left are the acceleration values that were extracted from his run. These are the maximum values, lateral deceleration and longitudinal acceleration g-force values. The acceleration g-force values vary as a function of velocity. They're not constant with velocity. This is a friction circle. On the left and right hand side here are left and right hand turns. That's lateral acceleration. This is longitudinal. The top is acceleration, the bottom is deceleration. This blue box surrounding it comes from the calibration data set. For example, at the bottom of the box is the deceleration. The limits of the box on the left and right are the lateral g-force values. And at the top of the blue box is the acceleration is roughly 0.6 g. It looks linear, but it's not. All the dots in between, the colored dots and the white ones, are the actual run data. The colors, I'll explain what they mean in a moment. Let's take a look at the results. On the left is a map with his racing line and some colors on it, the same colors. This is a plot of velocity versus time. You can think of time as following along the racing line from the starting line. See the start line in green and the finish line in red. There are two curves, a blue curve and a white curve. Sometimes they are coincident. You can see this is an acceleration event here, and they overlay. Same here and same here. They overlay because of the calibration. You can also see some on the deceleration. I don't really want you to look at where they line up. I want you to look at where they don't. For example, you can see a loss of velocity here, a difference between the simulation, the blue line, and the actual run line, the white. And that is due to excessive deceleration. You can see here, where it's yellow, he should have continued to accelerate, but he stopped short and actually decelerated, losing a considerable amount of velocity and a considerable amount of time. Another area where a considerable amount of velocity was lost is at the tail end of this deceleration event. And there are other places. Here there's a loss of velocity, and as well as there, that are due to decelerating when should have continued to accelerate. And these are just some examples that he could look at after his run and then make some adjustments on the following run. One thing we can do with this program is actually race against the simulator. So I'll do that. And the blue circle is the actual simulation, and the red circle is Don. And Don, if he had at every point along the racing line achieved the acceleration rates that we know he could do because we extracted them from his run, he would have kept up with the blue circle. But because of these areas where he lost velocity, he is losing ground and losing time, considerable amount. So you can see that these regions these areas where you are losing velocity are very significant. And this program will tell you where those areas are and what was the cause of that velocity loss. So let's now look at Landon's run. This is Landon's racing line, and you can see the g-force values, in particular lateral and deceleration g-force, are somewhat higher than Don's, and in fact they're extremely high. In some places his lateral g-force exceeded 1.5 g's, and these points there are represented on this curve here. Same thing with the decel, and I'll show you where those are in a moment. Now let's look at the results. Even Landon had some areas where he fell short. Here's one in particular where, I mean, he decelerated very abruptly before probably reaching the velocity he should have. And that caused a huge decrease in velocity, a huge time loss. And that's right here. And that happens to also be where he hit the brakes so hard, he had about 1.3 Gs of deceleration G-force. Here's another area here where he could have accelerated a little more strongly. It was a weak acceleration. And that's over here on the map. And those are a couple examples. Remember, in all cases, you're comparing against yourself. So these are just the areas where you did the worst on that run. Here's something else we can do that's kind of interesting. I can compare Don's run with Landon's run. Landon's in pink or red. Don is in green. And where you see on this racing line at dark red or even light red, velocities were faster. The darker the color, the faster the velocities. Difference. And in green, Don was faster. And we can race the two. This is almost in real time because each jump that you're going to see is about a second of actual run time. And it's also roughly a second of time on this video. So this is almost real time. And you can see Landon's in the lead. But Don's keeping up somewhat. And as you come around this corner, Don will probably gain a little ground. You can see maybe a little on Landon. But then Landon takes off again. So it's a kind of an interesting comparison when you have co-drivers, or even comparing against yourself. This could be your first and your second run that you're comparing against yourself. Either way. This just happens to be Don and Landon. I want to make one last comment. Those of you who are familiar with SoloSim, a company who makes that as Petrel Data Systems. And Petrel Data Systems was interested in my program. And I shared a lot of the information with them. And they're actually going to be developing their own version of something like this that is based off of this program.